Hello, class. Well, I'm not here today. I'm probably heavily medicated and laying in my own bed. But you still have to learn, and it's very dark, so you probably can't see my hand moving. But anyway, this week what y'all are going to be looking at is kinematic equations. Should be pretty straightforward for y'all to be able to work on your own with a little bit of nudging from me, hence the video. So, as always, we're using physicsclassroom.com. I'm on the main page right now. If you click on physics tutorial, which is the one that we always pick, and then 1D kinematics, and I'll make it a little bit bigger for you now. And then we are on lesson 6. So if you scroll down on 1D kinematics to lesson 6, we'll start off with kinematic equations. So the last section that we did was pretty much graphing the motion of objects using position time graphs and velocity time graphs. We looked at how slope related to velocity on a position time graph and how slope related to acceleration on a velocity time graph. And then we did some calculations. The last thing really that we did was some calculations on distance in a velocity time graph. But spoiler alert, you don't have to have a graph to do this. Smart people, they put together some equations that pretty much take care of doing some of those calculations for you. There's actually four equations that you have to learn. Now, this year I only have academic, so I'm letting y'all use the equations because they're on a formula chart. But you still got to use them. So here they are. The 4 kinematic equations, and they address it as the big 4, is displacement is equal to VI times t plus 1/2 AT squared. That be displacement is equal to initial velocity times time plus 1/2 acceleration times squared. Velocity final squared equals initial velocity squared plus 2AD. Velocity final equals initial velocity plus acceleration times time. And then finally, displacement is equal to initial velocity plus final velocity over 2 times t. Really, the thing to look at on this is not so much you worrying super hardcore about the equations, because typically that's what I would say is the hardest part of the section, is the memorization of it, because the utilization and the plugging into the equations is rather simple. But since you're getting the equations, you only need to know a few things. And here's the things you have to know. There are 5 variables, five variables. As I described to you before, it was D, and that is displacement. This is VF, final velocity. VI, also sometimes you see this little VO, it's actually V0, also stands for V naught. We've talked about that one, but I'm just going to remind you. V naught, and that's initial velocity. Then we have A, which is acceleration. And then we have T, which is time. So we have 5 variables, five variables. The catch that they're going to get you with is they're going to give you a problem. That problem doesn't have 5 variables in it. It doesn't even have 4 variables in it. It gives you 3. You get, on any question, you get 3. Now, they may make it look like you have 2, but one's understood. But you always get 3 variables. And it's your job to fill in the 4th. But the kinematic equations come to the rescue here. So we take a look at any of the kinematic equations, you're going to notice that one's missing on pretty much all of them. We got D. There we go. We got VI. We got T, and we got A. What happened to my final velocity? Well, in the case that you don't have a final velocity, use this one. That's the one you got to use. What one is this one lacking? Well, if I don't have a time, no time, no problem. Use this one. And as you follow along, this one's going to be having, this one lacks a displacement. And this one lacks an acceleration. So, 4 equations, 5 variables, and well, what happens if I don't have an initial velocity? Oh, if you don't have an initial velocity, you have no clue what you're going to do, because we have to know what is happening to start off. If we don't have an initial velocity, we can't tell anything about where we're moving to, because we don't know where we're coming from. We really have to know how fast you are starting off so that any of the other ones make sense, because if you are already in motion, your current velocity will affect your distance. If we know a final but we don't know an initial, then you can't really tell me acceleration because you don't know how much the change is. If we do know acceleration but we know no final, then we can predict it. But you always, 100%, always have to have an initial velocity. If you don't, you are missing the point on something. They're hiding it. They might have said this word, R-E-S-T, rest. If they say starting at rest, from rest, it was beginning from rest, that means 0, no initial velocity, 0 if it's in miles per hour, if it's meters per second. They're sort of setting you up there. Even though they didn't specifically say initial velocity, it's there. Trust me, it's there. There's always going to be an initial velocity. They're going to have to tell you that. So I think we're going to conclude this video. What I'm going to start looking at is doing some of the problems. So I'll see y'all in the next video.